We are looking at interpreting data displays. You should have this in front of you. Interpreting data displays. Okay. First thing we're going to do is what we've done a bunch of times. We're going to make a dot plot of the data. Okay? So we're going to put a dot at 75. We're going to put a dot at 73. We're going to put a dot at 72. We're going to put another one at 75. Another one at 73. One at 76. And one at 90. And two at 95. Oh, I missed one. 75. Okay, now I'm going to add them all up and divide by how many there are. Let's go. Guys, try it out. Don't wait for me. Add them all up, divide by how many there are. 79.9. It is 79.9 is the answer. Okay, what is the median of the data? What's the middle of the data?
75. Oh my God.
It is 75. What's the mode of the data? Which one's most common?
75.
Okay. Which measure of the center, mean, median, or mode, seems to best represent the average?
Median.
I would say median.
How did you find your answers, Kayla? Because it's the middle is the main.
Okay. How do the mean, median, mode change if we drop the last 3 days? So if we drop 90, 95, and 95, what would the new mean, median, and mode be? And I'll wait a second for you guys to do that.
Median is middle.
Median is the middle one. Like if you put them in from order of least to greatest, it's the middle number. Mode is the most common. Mean is if you add them up and divide it by how many there are. Okay. You guys need another second? Okay. My new mean is 74. I get 74.14. Okay. New median.
75.
New mode.
75.
Okay. So do you guys get why we use the median? Because these are kind of outlier-ish for it. Because our temperature really wasn't anywhere close to 79 most of the time. Okay. So this is skewed data. Okay? If all of the data points are to the left, we say it's skewed to the right. The opposite way you think. Skewed to the right.
Skewered.
Okay? The mean is greater than the median. Okay? We're going to do the same thing for the rest of these. We're going to figure out if it's skewed to the right, left, or symmetric. Okay, that's the whole thing.
What do you mean by skewed?
Skewed means like if more of the data looks like it's to the left, we call it skewed to the right. If more of the data looks like it would be to the right, we'd say it's skewed to the left. If it's symmetric, it's even on both sides. Okay? And if it is skewed to the right, the mean is greater than the median. If the mean is less than the median, it's skewed to the left. If they're equal, it's symmetric. Okay, so let's look at this bottom one. The parking data is considered symmetric. Okay, see how it looks pretty even? Both sides look about the same. Okay. There are about the same number of data points on either side of the center. That means the mean is the same as the median. So if the mean's 25, the median is probably 25 as well. All right, well, let's move to the next one. Skewed to the left, yeah.
Why do you say the opposite?
I think it's like kind of telling you there aren't good stuff on that. There's not a lot of data on that side. So it's not where that there's more data, it's where there's the less amount of data. Skewed to the left. There are a lot of points to the right of the center. The mean is going to be greater than, less than. The mean is less than the median. Less than the median. Okay, so we're going to kind of put these in different orders. If we have symmetric data, the relationship of the mean and median is the same. And it kind of looks like that, right? I got a little visual. Okay, so if it's skewed to the left, the mean is less than the median. It looks like they didn't like it.
Just do the graph.
It just gets bigger as it goes to the right.
Okay. Skewed to the right. And if we have the mean and we have the median, goes this way. Okay. All right. Now we are going to make the state sampled 60 farms to see how many horses they each have. And we're going to draw a histogram based on that table. How many horses do the farmers have? Okay, so between 0 and 4 we have 2. Between 5 and 9 we have 7. Between 10 and 14 we have 23. Between 15 and 19 I have 19. Between 20 and 24 I have 7. And between 25 and 29 I have 2. Okay. The mean, this says, is 13 and the median is 10, so the data is skewed to the,
It's symmetric.
It'd be to the, skewed to the. It looks pretty symmetrical to me. No, it'd be.
I think this is incorrect information. Because I don't see how that could possibly be true. Because I think this looks very symmetric.
Well, what about the one?
Hmm?
What about 15 to 9?
15, like, these are very close to being the same, right? And then these are the close to being the same, and these are close to being the
So
same.
it's just if they're close.
So I think it looks symmetric. Like, the majority of your data is in the middle. All right, let's look at the next one. Okay. Is this skewed to the right, to the left, or symmetric?
Skewed to the.
Skewed to the left.
What can we tell from the data? We can tell that most men are shorter than the median.
What's the median?
Well, when it's skewed to the left, we know that when it's skewed to the left, we know the mean is less than the median. So we know the majority of people are smaller. Okay. What about this one? What does this one look like to you guys?
Symmetric.
Symmetric. So most men are close to the median in height. Okay. Here's our box plot. This might be a little harder to tell. Is this skewed to the right or to the left?
To the right.
Good. Skewed to the right. Which means what? Most men are taller than.
Why is it skewed to the
So most of the information, see this box right here? It's to the left.
I didn't do that.
right? Wait, but isn't it more than right?
Remember, it's the opposite. If it's on the right, we call it skewed to the left. If it's on the left, we call it skewed to the right.
Yeah, but is it more information on the right?
More information is on the left. Because this is 50% of our population is in between the box. This little line here just means it's showing you what the max
Right,
is.
but isn't the right box more than the left?
Yeah, but you're looking at the overall graph. So between here and here, see how the box is closer to this side? That means it's skewed to the right.
Oh, no, please.
Okay, let's make our fun and exciting histogram.
You lost me when you said that.
Okay, so I'm just going to go through each of these. A golf realtor is concerned what the golf balls are heavier than the allowed weight of 46 grams. He selected 25 golf balls at random and weighed them. Here's the data. So if this is 43, I'm putting that in the 43 box. 45 goes in the 43 to 45 box. 41. Is this making sense?
Yeah.
There, that's right. Okay, remember all the different ways to do mean too, because you don't have to go through it. Go ahead and try to answer these questions.
Would the shape of the data be like, what we just talked about?
Skewed, yeah. We ready? All right, what'd you guys get for the mean?
43.0.
What did you guys get for the median?
I still working on it.
43. Median should just be 43. 43 was the most one. What's the shape of the data?
To the left.
Skewed to the left. All right, should the golf ball guy worry that his golf balls are more than 46?
No.
Why?
Because the one has 1.6.
Only one that's more than 46. 46 or more. Okay, the Realtor Officer Manager redid his test using more golf balls. Here's her histogram. How does her data compare to his? Hers is skewed to the right. There's way more golf balls. Okay. If all the golf balls came from the same shop, how can her data be so different than his?
Because she's a female.
Oh, that's sexist.
Oh my god.
What? It doesn't have anything to do with her being a girl and him being a boy.
Well, I mean, they have different sized clubs for girls.
No, these are golf balls. These are the
Well, I
same
mean,
shop. I think it's just hers. They're so different. Like, still look between
This is
43 and
fine.
45 and 46. That's where the most of them are. She just had way like they just looked at way more golf balls.
Well, isn't it random?
That's gonna be like one of those police things.
It's gonna be SJW.
Guys, focus. So I just think the more golf balls you look at, the more you're gonna have a more accurate shape of data. Okay, let's look at lights.
Wait, what was
She looked at way more golf balls. The more data you look at, the more accurate you have. You look at.
Isn't it random?
Look how many more balls she has than golf balls she looked at than he looked at. Grace, you can leave if you can't pull it together. Knock it off. She looked at way more golf balls, and the more data you look at, the more accurate the data is. Okay, let's look at mini lights lifespans. All right. Strings of decorative mini lights are supposed to last 1,000 hours with an acceptable error of plus or minus 50 hours. Data from 2 quality control tests are given. Okay, here's test 1, test 2. Create a box plot for each data. Then we're going to calculate the mean, media, and IQR for each data set. Then we're going to compare the shapes of the data displays. What do the boxes tell us about the quality of the mini lights? Okay, so go ahead, guys. I'm going to do mine, you do yours. Make a box plot of this. You can do it in your calculator if you want.
You want to do-
Remember, you can use your calculator and put it on your there if you would like. So we'll like make the list, then go through and change
1,000?
that part of the list.
Yeah, 1,000. Yeah, I don't know what the divide by 15 is. 1,000.
Is there an easier way than just to find the median other than like putting them all in order from least to greatest and then
To find the median,
yeah.
yeah, make a box plot out of it in your calculator and then hover over the middle of the box. Just gives it,
I think that's just as much time as.
I don't know, you enter it all in and it does it all for you.
Why don't I type out median and then like do the.
See what
parentheses?
happens.
Yeah, I will.
I don't know the answer to that. Okay, you ready? One more minute, guys.
Do we miss 1,000? Well, it's still 1,000. Maybe it's still 1,000.
Actually, no.
I got it this way and I got it in calculator. Let's test this thing. Don't know. 2.
Okay, so these are my two graphs. My first box plot, my second box plot. Test 1, my mean is 1,000, my median is 1,000, my IQR is 100. Test 2, my mean is 1,000, my median is 1,000, my IQR is 50. Comparing the shapes of the displays, what do the data plus tell us about the quality of the mini lights?
Hey guys.
Test 1 is more variable, right?
Guys, if you don't want to write out the entire like line order and then like cross it out to find the median, you just put it in the calculator. Just write out median. Yeah, it works. It really does.
Oh, when did you mean?
Yeah, just write out like with the median. With the mean, yeah, just write out median and then like the parenthesis, control, other parenthesis, and then just write out all the numbers. It'll give you the median.
I didn't see it.
And you don't have to put them in order from least to greatest.
And you don't have to, no, just any of the numbers.
Test 1, bigger IQR. So I would say in test 1 there's more variance. There's more possibility. It could last as little as this, as big as this. There's like a greater amount. Where this one, most of them are in a smaller area. Test 2 is better. Okay, you have your homework to do. What is it?
Okay, half of it then.
And you probably want to put your calculator away and take your stuff.